finally we ending the story of respiratory chain, and we coming to the final steps of oxidative phosphorylation and how it is regulated and how it is inhibited. How can I regulate the component of electron transport chain? How to control these reactions? What is the inhibitor of respiratory chain? And how can I differentiate between these inhibitors and uncoupler? What is the mechanism of actions of both? And lastly, the maternal inheritance of mitochondrial abnormalities. What is the genome of the mitochondrial genome and how it is inherited? It is from mother, not from father. Let's start this lecture. The main part that play a role in controlling of respiratory chain is availability of ADP. If the ADP is the main regulatory mechanism that controlling the oxidative respiration along the respiratory chain. Increasing ADP, this means that the cells has low energy state. When doing work, the ATP is converted into ATP. So whatever the work you do, the ATP, increasing concentration of ADP relative to ATP, this means that this is a signal to mitochondria to increasing its more respiration and more oxidation for more formation of ATP to re-establish the stores of ATP, converting more oxidation to forming more energy, and this is energy with capture information of ADP back to ATP. So ATP, the energy state of the low energy state of the cell, it is the main regulatory control of respiratory oxidative phosphorylation. Under certain conditions, the concentration of inorganic phosphate can be also affected because ADP is converting into ATP by through phosphate. So if there is limited concentration of inorganic phosphate, this reaction will be limited. Inhibitors of the respiratory chain, there are three mechanisms to inhibit respiratory chains, either by uncouplers or inhibiting the component of oxidation of the complex 1, 2, 3, 4 electron transport chain. And lastly, I can inhibit the oxidative phosphorylation by inhibiting only phosphorylation in the complex 5. So inhibiting the conversion of ADP into ATP. Let's take what these mechanism of inhibitor act and how can I differentiating between them. Starting with uncouplers. What means by uncoupler? Uncoupler protein create channels of inner mitochondrial membrane. Let me remember you, inner mitochondrial membrane, as oxidation is passing in respiratory chain, there is resulting in pumping proton to inner mitochondrial space. This proton is prevented from entry to the matrix because inner mitochondrial membrane is impermeable to it. And this creates pressures which is called electronegative pressure. Electrochemical concentrations of proton more positive in inner mitochondrial space relative to the matrix. Proton, this is the summarize of the previous lectures. Proton enters through complex 5 only, and this is activating ATP synthase to forming ATP. Yes? Suppose I'm making channels in inner mitochondrial membrane. So this is a mechanism of uncoupler. And this allows proton to be back to matrix without going to complex 5, which is ATP synthase. Proton channels F0 domains. So this is another mechanism of entry of the proton from this is the channels you make rather than entering through F0, which is stimulating ATP synthesis. Failure of formation of electrochemical gradient through increasing permeability of the inner membrane mitochondrial through the inner mitochondrial membrane. No electrochemical gradient will be formed. And so, abolish between coupling, oxidation, and phosphorylation. So, oxidation will be occur normally, and every one of the oxidation with the proton pump, and this the proton pump will be re-enter back to the mitochondrial matrix through the channels created by uncouplers. Phosphorylation is intact. No coming, no inhibition of phosphorylation, but okay, no activation of phosphorylation. Phosphorylation is this enzyme is acting. It is not damaged, However, we not stimulated this enzyme. This enzyme is stimulated by passing of a proton through the channels F0. But the protons have another challenge, so I don't activating this enzyme. I don't activating complex 5, but still it is working, but it is not stimulated, it is not acting. So this is uncoupler. This means by I uncouple, oxidation go, and the removing of the proton to pumping proton to inner membrane space, and they come back to the channels, and the energy is released as heat. No ATP is formed. ATP formation stops while oxidation is proceed. This is uncoupler. Phosphorylation, it is intact but it's not working while oxidation is proceed. And the energy, it is released as heat. No formation of ATP, no stimulation of ATP synthesis. This is another way of entry of proton. Uncoupling of oxidative phosphorylation, this results in increasing oxygen consumption. Oxidation is going, no, I don't damage or disrupt to the process of oxidation. Oxidation, consumption, and the formation of oxygen with the proton forming water, it is proceed. But instead, phosphorylation also, it is okay, it is not damaged, but it's not working. It is not active, it is not stimulated, because the proton is not passing to the inner mitochondria, to the mitochondrial matrix through the complex 5, ATP synthesis, by another channels. So the energy is resulting as heat, not as ATP formed. Production is electron flow. Proton pumping attempt to maintain electrochemical gradient. The proton pump, and still proton is okay in the mitochondrial membrane, and return back to the matrix in another normal way as it is supposed to be enter. Uncoupling proteins create a proton leak. Look here, this is the mitochondria, and through the electron passing through respiratory channels, when it is passing through the complex 1, 3, and 4, this is pumping of proton in inner mitochondrial space. This is the proton is positive. This is creating proton concentration, electrochemical gradient. And this is proton wanted to enter back to mitochondrial matrix. But it can't be entered because mitochondrial membrane is impermeable. That is what normally happens. It is entered through the complex 5, which is the F0 domains of the ATP synthesis. This is stimulating. This is the down entry of the proton down concentration gradient. This results in stimulation of enzyme. The stimulated enzyme converting the energy from ATP into ATP. If I having uncoupler, this is producing a sieve. So the proton can enter from any direction rather than through the entry. The proton can enter from here, here, and here. So oxidation is proceed, and the proton enter from any other side. This is the entry of proton result in production of heat, not production of ATP. So uncouple, remember, not inhibiting oxidation. Oxidation is proceed. They act as transporting proton to inside mitochondrial without passing from this. What is this? Which is F0, F1 domain. And the energy is released at heat. This is the mechanism of uncouplers. Oxidation is not coupled to oxidation. Oxidation occurs, and the energy resulting from oxidation is dissipated as heat, not as the formation of ATP. I separated the process of oxidation. It is not linked to phosphorylation. It is oxidation to phosphorylation. Is uncoupler is normally present in our body, or it is the pathogenic process? Uncoupler, again, this is the mechanism of action. It is allow proton to pass into mitochondrial matrix without passing in the complex 5, F0, F1. So no ATP is formed, and the energy released from oxidation is dissipated as heat. Again, my questions: is uncoupler is the pathogenic, or it is normally present inside our body? Actually, I have two types of uncouplers. Uncouplers, which is the physiologic, our body. As you know, in the cold weather, the heat, it is an important mechanism of the body to maintaining its temperature. So dissipating energy as a heat, it is useful in the body, especially in the cold weather. And also the animals, especially especially hibernating animals, which as the bear, which lives in very cold -degree, of course it is needing some energy to be dissipated as heat. This is uncoupler, which is normally physiologically present protein called thermogenin. Thermogenin presenting in the adipose tissue, our adipose tissue, especially brown. They are white and brown. The brown adipose tissue is present in the people who live in cold weather, and also as a newborn, or some people and some animals lives in a cold weather. This is a thermogenin making oxidation to proceed, but the energy resulting from this oxidations not captures, as I said, for ATP, but it is formation dissipated as heat. And still I want this type of heat. But when reaching to pathological level, which is synthetic uncouplers, as 2,4-dinitrophenol. 2,4-dinitrophenol, it is the lipophilic proton carrier. This is a compound is toxic, which is present especially in large toxic dose. This is producing proton carrier. This is decimated. This is remove the electrochemical gradient, taking the membrane to diffuse the proton to diffuse through any part of the mitochondrial membrane. No electrochemical gradient, no high concentration gradient in the mitochondrial membrane, no stimulation of F1, F0, F1 complexes and no formation of ATP. If it is reaching a high level, no ATP, it may be result in this, because I need ATP for neuromuscular transmitter and for CNS electrolyte transmitters and for heart rate, for respiration. Decimating, if I deprive from this ATP, this of course leading to this, especially in high dose. This is a mechanism of uncouplers. I can inhibit the respiratory chain through number 1, uncoupler. Number 2, through inhibition of respiratory chain complexes itself. This inhibitor acting in 3 sites. Of course, it is at the site which are passing electrons through this site, resulting in pumping of the proton, which is the complex 1, 3, and 4. Inhibition of the complex 1, so no electrons can be passing from this part, like barbiturate and insecticides called rotuline. I can inhibit complex 3 through wear gases and actinomycin. Complex 4 is inhibited by carbon monoxide, hydrogen sulfide, and by cyanide. Look here, if this I obstructed this pathway, so all the other pathway will be inhibited. Obstructed this pathway, all the coming pathway is inhibited, and so and this and so on. So if complexes of all of this will be inhibited the pathways and inhibited the energy. The energy produced from no respiratory chain is present, no oxidation through it, no phosphorylation, and the ATP is 0. However, in complex 3 and this is a complex 4 and 3 and 4, this is no oxidations and no phosphorylation. But look at complex 1, which is barbiturate. Barbiturate or rotuline, it is inhibiting the passing of oxidation from non-dehydrogenase. So think with me, if this resulting in no ATP is produced, no ATP is produced if it is using this barbiturate. What is your answer? No. If I blocking this part, as you know, in Q, it is collecting hydrogen from complex 1 and the complex 2. If the obstructing this pathway, so I can generating ATP from FAD. FAD, succinate dehydrogenase, enter Q from here and passing like this and resulting in 2 ATP is producing per each molecule is the FAD. So the complex 1 inhibiting the passing pathway oxidation of NADH, like not inhibited the oxidation of FAD-H2. However, if I use complex 3 and the complex 4, this is inhibiting the common pathways of oxidations and no ATP will be produced from oxidative phosphorylation. They synthesize ATP especially in the CNS, causing this. Inhibited. Okay, to inhibiting ATP production, I said there are 3 types. Number 1, uncouplers. Number 2, by destroy the respiratory chain component complexes. Number 3, by destroying complex 5, by preventing phosphorylation of ADP into ATP. This is, as example, is oligomycin. Oligomycin, it is completely block F0, so the causing the proton channel, completely closing it and preventing its re-entry. So it is inhibiting ATP. So it is inhibiting the synthesis of ATP. The proton here in the inner mitochondrial space, it is the large present in large concentration. The proton electrochemical gradient, this is the inner mitochondrial space, and this is mitochondrial matrix. The only pathway of passing of protein, it is passing through this unit, which is F0. Oligomycin block the passage of this proton. Look to me concentrating well to differentiate between uncouplers and inhibiting of phosphorylation. What is meant by uncoupler? Uncoupler, making this is the proton which is pumping in inner mitochondrial space to enter from any side of the membrane rather than the F0. So the energy is producing as a heat. Oxidation, it is occur, and the no phosphorylation. No phosphorylation is working, but proton it is returning again. So the process will be continue. Oxidation, proton, and coming from any side. Heat, oxidations, pumping proton, and they come from inside. This is the uncoupler. Production at heat. But the story is completely different with inhibitor of phosphorylation, because oxidations and pumping proton, this is the gradient. Proton want to return again. No. The inner mitochondrial membrane, it is impermeable to the proton. And F0, it is blocked. So accumulation of proton in inner mitochondrial space, this resulting in large accumulation, high concentration. This is a high proton. What will be happen? This will be inhibiting oxidation. Because the pH and electrical gradient can't be dissipated. Can't be dissipated. How can it be dissipated? It is accumulated here. No ways of the proton to enter mitochondrial matrix. Even the only way it is a block. No other pathway as uncoupler. The proton here, it is large, can't be dissipated. It is accumulated, which with each oxidation, it is accumulated. Electron stop passing. Electron stops oxidation because of difficulty of pumping any more proton. I can't pump any more proton, okay, because of its high concentration. This again is a step high concentration gradient. So this is the preventing back of proton will be inhibiting more pumping of the proton, so it is inhibiting oxidation. But in uncouplers, the oxidation is proceed. In uncouplers and inhibition of phosphorylation, no ATP. But additional to inhibiting phosphorylation, in uncouplers, oxidation is proceed, while inhibiting blocking oligomycin, blocking F0, this result blocking both phosphorylation and oxidation. What is the inherited defects on oxidative phosphorylation? It is occur to the inherited defect oxidative phosphorylation. It results from alteration of mitochondrial DNA. Mitochondrial DNA mutations, it is the high greater incidence and is about 10 times as it occur in the DNA. Tissue, the greatest require of ATP will be affected if it is no oxidative phosphorylation, no ATP. So the most cells depending on ATP as a CNS, skeletal muscle, and the heart will be more affected from this deprivation. The oxidative phosphorylation requiring 90 polypeptide. 13 of this polypeptides, it is forming by mitochondrial genome, and the other. So it is a needing for oxidative phosphorylation. I needing 90. This 90 out of them is 13. It is sensitized by mitochondrial DNA, genome of the mitochondria. While the remaining part of 90, it is sensitized by genome present in nuclear DNA, sensitized in cytosol, and then coming back to mitochondria. DNA, it is high fidelity. the high mutation it is occur in mitochondria, affecting this 13 part of the protein and affecting the oxidative phosphorylation. What do you know about mitochondrial DNA? This is the mitochondrial DNA. It is a cellular DNA. It is derived from mother ovum. Fertilization, the mitochondria it is of the zygote, it is derived from the ovum, not from the sperm. It is the mitochondrial genome containing about 37 genes. As I said, 13 proteins of electron transport chain. This is responsible for the synthesis of the SAM, transfer, and ribosomal RNA. What are the abnormalities of mitochondrial genome? As I said, the mutations in mitochondrial DNA is more common, and it is about 10 times it is more common than the mutations in nuclear DNA. There are two clinical disorders associated with abnormalities of mitochondrial DNA, as mitochondrial myopathy and Leber hereditary optic neuropathy. What is the mitochondrial myopathy? This is the mutations of the DNA of the mitochondria, especially of the muscles. Mutation of mitochondrial of the muscles, so it will be affecting the 13 proteins affecting oxidative phosphorylation. No oxidative phosphorylation, this resulting in decreased ATP produced in the muscles. So the muscle will be characterized by myopathy, which is the muscle weakness, cramping, and wasting of the muscle. Another clinical disorder of mitochondria, it is called Leber hereditary optic neuropathy. It is a disease. From its name, this is a disease resulting from defective mitochondria of the optic nerve, and this results in decreasing ATP, which result in central, with bilateral loss of the central vision, which result in neuroretina degeneration and the damage of the optic nerve. The hereditary mutations of the mitochondria is important error of mitochondrial DNA is coming from the mothers, because the mitochondria of the sperm does not enter the fertilized egg. This is come with referred to the mothers, not from the father. Yani if the father having this disease, their outcome will be not having. But this is disease, it is inherited from the family mothers and her families, because this is the mutations of mitochondria, and this is mitochondria coming from ovum and not from sperm. Okay, alhamdulillah, we're finishing the oxidative phosphorylations, and let's taking some questions about the compounds that regulated the respiratory chain, and how it is regulated and how it is inhibited, what is the different mechanism of inhibition, and how it is the most common clinical disorders of mitochondrial genome. Starting our first question, when dinitrophenol is adding to mitochondria? What is dinitrophenol? Yes, dinitrophenol, it is one component of uncouplers. This is uncoupled oxidative phosphorylation. Dinitrophenol is example of the uncouplers. We're taking it as synthetic uncouplers. Let's read our other choice. This decreases the flow of electrons through cytochrome oxidase. No, in uncoupler oxidation is proceed. It is not affecting, resulting in increase ATP. No, uncouplers decrease the formation of ATP because the proton it is enter from other side than ATP synthesis. Increase the rate of ATP. No, uncouplers decrease rate of ATP phosphorylation, but oxidation is proceeded. So it is uncoupled oxidations and phosphorylation. In mitochondria, we blocked at the site of NADH oxidation, and we're treated with succinate as aspartate. What is the BO ratio? This is the inhibitors of the complexes. We inhibited the complexes starting from NADH oxidation. But if this I wanted to join this is respiratory chain starting from complex 2. So PO will be the same, 1 more than normally, or 1 less, or 0. It is the same. Why? Because as we said that when I'm starting the respiratory chain from succinate dehydrogenase, it is a complex 2. Yes, this results in pumping proton, which is when the electrons is passing from the complex 3 and 4. 3 and 4 were producing 2 ATP. Inhibiting complex 1, when I start, it has no affecting on my starting here. I started from complex 2. Complex 1, it is the one steps before, and it is not affecting me. So it is the same. It is inhibiting complex 1, starting from complex 2, producing 2 ATP. If the complex 1 is acting, this is not adding to me, I will still passing from complex 2, which also producing 2 ATP. So it is the same amount of energy. PO ratio will be produced. Mechanical disruption of inner mitochondrial membrane will result. What is the mechanism of this? Mechanical disruption inner mitochondrial membrane will result in this is the same mechanism of uncouplers. This is inhibiting building up proton gradient. The proton will be enter from any part from disrupted membrane. So no electrochemical gradient, no concentration gradient, no energy for ATP formation. Uncoupled oxidation of phosphorylation. This stimulate oxidation? No, this oxidation is occurring as the same. It is not stimulated. Inhibition of a stepwise transfer of electron. This is not inhibited. Oxidation it is proceeding. Stimulation of phosphorylation? No, phosphorylation is not stimulated and it is not working. Thermogenin is a protein that, again, what is the thermogenin? Thermogenin, it is the physiological uncoupler of respiratory chain. It is uncoupler. It is this. It is a very easy question. The rate of respiratory chain is mainly controlled by concentration. Which part of this controlling mainly concentration of respiratory chain? Of course, it is ATP. To less extent, inorganic phosphate can also control, but is the main control of respiratory chain mainly is occurred due to. Thank you.